quantum physicists decided to determine if time could spontaneously reverse itself. The study could be seen as an attempt to violate the second law of thermodynamics. That law is closely linked to the notion of the arrow of time that asserts the one-way direction of time from the past to the future. The researchers said they artificially created a state that evolves in a direction opposite to that of the thermodynamic arrow of time. They used an IBM quantum computer to reverse the aging of one simulated elementary particle by 1/1,000,000th of a second. This requires manipulations, meaning that it is not likely to happen naturally, as the aging of even a single particle is still too complicated for nature to reverse. The quantum computer used in the experiment had only 5 qubits. A qubit, or quantum bit, is the basic unit of quantum information. The time reversal experiment required 4 steps. First, the qubits were placed in a normal initial state that mimicked an artificial atom. Then the qubits were entangled so that whatever happened to one qubit affected the measurements of the other one. The team then hit the qubits with a series of microwave radio pulses, which transformed the qubits from a simple state into a more complex state. After a millionth of a second, the scientists then paused this phase and treated the qubits with another microwave pulse to reverse the phase. Finally, the team turned the halted phase back on. The qubits went back to their original alignment, or back to their own past. The researchers concluded that the qubits got a millionth of a second younger. The algorithm almost always worked when 2 qubits were used. It successfully returned the qubits to their youthful states 85% of the time. However, when the experiment used 3 qubits, the success rate fell to half the time. Ultimately, it will take computers with hundreds of qubits to achieve the quantum mathematicians' ambitious goal. When such computers become available, the time reversal algorithm could be used to test them.